Hi guys, welcome to 5% Academy. Today we will learn about rational numbers. So let's start. What are rational numbers? A number of the form p by q where p and q are integers and q not equal to 0 are called rational numbers. For example, minus 4 by 7, 6 by 13, 9 by minus 17, 0 by 1, minus 2, etc. We all know what are integers. All whole numbers plus all negative numbers are together called integers. For example, 0, 2, 4, minus 8, minus 20, etc. Now we'll discuss about the properties of rational numbers. There are three main properties of rational numbers. First one is closure property, second is commutativity, and the third is associativity. So let's start with the closure property. 0 plus 5, they both are whole numbers, gives the result 5, which is also a whole number. Since two whole numbers are giving the result whole number by adding these both numbers, so whole numbers are closed under addition. Now we'll talk about subtraction. 2 minus 5 equal to minus 3. These two are whole numbers, but their result is minus 3, which is an integer. So whole numbers are not closed under subtraction. Now multiplication. 4 into 3 equal to 12. All these three are whole numbers. So whole numbers are closed under multiplication. 5 divided by 11 equal to 5 by 11. 5 is a whole number, 11 is a whole number, but 5 by 11 is a rational number. Since two whole numbers are not giving a whole number on division, so whole numbers are not closed under division. Now let's talk about integers. Minus 4 plus 2 equal to minus 2. These both are integers and their result is also an integer. So integers are closed under addition. Now for subtraction, minus 4 minus 8 equal to minus 12. Both these are integers and their result is also integer. So integers are closed under subtraction. Now let's talk about multiplication. 2 into minus 3. Both of these are integers and the result is minus 6, which is also an integer. So integers are closed under multiplication. Now let's discuss about division. 3 divided by 7 equal to 3 by 7. These both are integers and the result 3 by 7 is a rational number, not an integer. So integers are not closed under division. Now we'll discuss about rational numbers. 3 by 8 is a rational number, minus 5 by 7 is also a rational number, and their result gives minus 19 by 56, which is also a rational number. So rational numbers are closed under addition. Now let's discuss about subtraction. Minus 5 by 9, minus 2 by 3. They both are rational numbers, and their result is minus 11 by 9, which is also a rational number. So rational numbers are closed under subtraction. That is, for any two rational numbers a and b, a minus b is also a rational number. Now let's talk about multiplication. Minus 2 by 3 into minus 7 by 5 equals to 14 by 15. They both are rational numbers and the result is also a rational number. So rational numbers are closed under multiplication also. Now for any rational number a divided by 0 is not defined. So rational numbers are not closed under division. However, if we exclude 0, then the collection of all other rational numbers is closed under division. Okay guys, let's go a little back. Come to this box. This box gives us the overview of all the closure property about rational numbers, integers and whole numbers and natural numbers that we have discussed till now. So have a look at it. Okay, let's go forward. Now let's discuss about the second property, which is commutativity. A dot B equal to B dot A, where dot is an operation. This is known as commutativity property. Now let's first talk about whole numbers. 0 plus 7 equal to 7 plus 0 equal to 7. Both these results are equals to 7. So whole numbers are commutative under addition. Now let's talk about subtraction. 0 minus 8 gives minus 8 and 8 minus 0 gives 8. Minus 8 is not equal to 8. We all know that. So subtraction is not commutative for whole numbers. 0 into 4 gives 0 and 4 into 0 also gives 0. Now consider another example. 2 into 5 gives 10 and 5 into 2 also gives 10. So multiplication is commutative for whole numbers. Now let's discuss about division. 0 divided by 6 is 0. And 6 divided by 0 is not defined. Since 0 is not equal to not defined, so division is not commutative. Let's consider another example also. 2 divided by 3 is 2 by 3 and 3 divided by 2 is 3 by 2, which these both are not equal to each other. So division is not commutative for whole numbers. Alright, let's move ahead. Let's discuss about integers. 2 plus minus 3 gives minus 1 and minus 3 plus 2 also gives minus 1. So addition is commutative for integers. 2 minus minus 5, which is 2 plus 5 equal to 7, and minus 5 minus 2 is minus 7. Since 7 is not equal to minus 7, so subtraction is not commutative for integers. 3 into minus 8, which is minus 24, and minus 8 into 3 is minus 24. Both of these are equal, so multiplication is commutative for integers. 3 divided by minus 7 is 3 by minus 7, which is minus 3 by 7. And minus 7 by 3 divided by 3 is minus 7 by 3, which is minus 7 by 3, of course. Since both of these are not equal to each other, so division is not commutative for integers. Let's come to rational numbers. Minus 2 by 3 plus 5 by 7, which is 1 by 21. And 5 by 7 plus minus 2 by 3 is also equal to 1 by 21. So addition is commutative for rational numbers. Now let's go for subtraction. 2 by 3 minus 5 by 4 is minus 7 by 12. And 5 by 4 minus 2 by 3 is 7 by 12. Since these both are not equal, so subtraction is not commutative for rational numbers. Alright, let's move ahead. Minus 7 by 3 into 6 by 5 is minus 42 by 15. And 6 by 5 into minus 7 by 3 is also minus 42 by 15. So multiplication is commutative for rational numbers. Minus 5 by 4 divided by 3 by 7, which is minus 35 by 12. And 3 by 7 divided by minus 5 by 4 is minus 12 by 35. Since these both are not equal, so division is not commutative for rational numbers. Let's come to the final property at last. Associativity. A dot B dot C equal to A dot B dot C, where dot is an operation. This is the associativity property. Now come to whole numbers first. 1 plus 2, which is 3, and 3 plus 3 is 6. And 1 plus 2 plus 3 is 1 plus 3 plus 2 is 5. So 1 plus 5, which is 6. So since these both are equal, so addition is associative for whole numbers. Now come to subtraction. 1 minus 2 minus 3. First 1 minus 2 will solve, minus 1, minus 3, minus 4, and 1 minus 2 minus 3, which is 1 minus minus 1, minus minus plus, 1 plus 1 is 2. Since minus 4 is not equal to 2, so subtraction is not associative for whole numbers. Now let's check for multiplication. 0 into 2 into 3, which is 0 into 2 is 0, and 0 into 3 is also 0, so the result will come 0. And for this, 0 into 2 into 3, 2 into 3 is 6, and 6 into 0 is 0. Since both these are equal, so multiplication is associative for whole numbers. Now let's come to division. 1 divided by 2 divided by 5, 1 by 2 divided by 5, 1 by 2 by 5, so 1 by 10. Alright, because 2 will come down and this will multiply and the result will come 1 by 10. Now let's check for this. 1 divided by 2 divided by 5, which comes out to be 1 divided by 2 by 5, 1 multiplied by 5 by 2, which is 5 by 2. Since 1 by 10 is not equal to 5 by 2, so division is not associative for whole numbers. Let's come to integers now. Minus 2 plus 3 plus minus 4, which is minus 2 plus 3 is 1, plus minus 4, which is minus 3, and minus 2 plus 3 plus minus 4, 3 plus minus 4 is minus 1, and minus 2 plus minus 1 is minus 3. Since these both are equal, so addition is associative for integers. 5 minus 7 minus 4. This gives minus 2 minus 4, which is minus 6, and 5 minus 7 minus 4 is 3, 5 minus 3 is 2. Since these both are not equal, so subtraction is not associative for integers. Now let's check for multiplication. 5 into 7 into minus 3. This is 5 7s are 35 into minus 3, which comes out to be minus 105. Okay. And 5 into 7 into minus 3 is 7 into minus 3 is minus 21. Minus 21 into 5 is minus 105. Since these both are equal, so multiplication is associative for integers. Now let's check for division. Minus 10 divided by 2 divided by 5. Minus 10 divided by 2 is minus 5 divided by 5, which is minus 1. Minus 10 divided by 2 divided by 5. 2 divided by 5 is 2 by 5. Into divided by minus 10. So sorry, my bad. This is minus 10 divided by, and this comes out to be 2 by 5. Alright. And then minus 10 into 5 by 2. So 2 5s are 10 and 5 5s are 25. So this comes out to be minus 25. Since minus 1 is not equal to minus 25, so division is not associative for integers. Now let's move ahead. Now you can similarly check out for rational numbers also. It's very easy. For rational numbers, addition is also associative. Subtraction is not associative. Multiplication is associative, but division is not associative. Alright. Now let's see what's the role of 0. A plus 0 equal to 0 plus A, which gives us A, where A is a whole number. Alright. B plus 0 is equal to 0 plus B, which gives us B, where B is an integer. Similarly for rational number, C plus 0 equal to 0 plus C, which gives us C, where C is a rational number. Therefore 0 is called the additive identity for integers, whole numbers and rational numbers, because whatever we add to 0, we get that number. Okay. Now let's check the role of 1. 5 into 1 equals to 5, which is also equal to 1 into 5. and minus 2 by 7 into 1 is equal to 1 into minus 2 by 7, which gives us minus 2 by 7. So we get the result a into 1 equals to 1 into a equals to a. Therefore 1 is called the multiplicative identity for rational numbers, because we can see whatever rational number we multiply with 1, we get that rational number itself. In this case, we get a into 1 equal to 1 into a equals to a, where a is a rational number. Now let's see the negative of a number. 2 plus minus 2 equals to minus 2 plus 2 equals to 0. So we get the conclusion a plus minus a equals to minus a plus a equals to 0, where a is a rational number. So minus a is the negative or additive inverse of a and vice versa, because when we add minus a rational number to a rational number a, we are getting 0. So minus a is an additive inverse of a rational number a. Alright, let's move to the final topic of this video, which is reciprocal or multiple inverse. C by D is called the reciprocal or multiplicative inverse of another non-zero rational number a by b if a by b into c by d is 1. For example, 21 by 8 into 8 by 21 gives us 1. So 8 by 21 is a multiplicative inverse of 21 by 8, or vice versa. I hope you enjoyed this video. Please like, subscribe and share. Thank you.